Hey everyone, I'm going to take you through one of our math slides here so you can see how they work and what I expect as you work through them. Starting with the last week, on the 21st here, I added the number of the day. So every day you're going to have a different slide with a different number. And what you're supposed to do with the number is show the number in different ways and do some different things with it. So for this example, this was on May 21st. This is the number 674. And you need to write it in expanded form, decide if it's even or odd, tell how many hundreds, how many tens, how many ones, model the number using the base 10 blocks over here. Just drag those over into the empty space here. Then you're just going to count forwards, backwards, or more or less. And I think with some of the newer ones, I've got some multiplication and division, some doubling and halving and things like that in the other ones. But let's take a look at this one first. So 674 is, in expanded form, we would write that as 600 plus 70 plus 4, since that's what the number means. 674 is an even number, so we can pull the circle over to the even. Right? It ends in a 4. And even means that when you divide a number into two groups, you can make two equal groups from that. 674 can be broken into two equal groups. That's why we call it an even number. All right. 674 has 6 hundreds, 7 tens, and 4 ones. And we can model that with the base 10 blocks. We have 6 hundreds, we can just pull 6 hundreds over. There's 3, 4, 5, and 6. 6 hundreds, 7 tens. We're going to pull 7 tens over here. 2, 3, 4, 5, 6. Got some missing over here. 7. Okay. And then 4 ones. 1, 2, 3, and 4. Like that. So that is modeling it. 6 hundreds, 7 tens, and 4 ones. 6 groups of 100, 7 groups of 10, 4 groups of ones, and that's what 674 means. So we model it there. We write the digits. These are called digits, right there. And then we're just going to fill in as we go, forwards by 2. So 674, 676, 678, 680, 682. Backwards by 3. 671, 668, 665, 600 and, oops, I did 85 there. That's not right. 662. Forwards by 10, 684, 694, 704, 714. Backwards by 11. 663, 652, 641, 630, like that. Backwards by 11. One more. Oh, this is so simple, right? That's why I gave these to you. 675. One less is 673. 9 more is 683. 10 less is 664. 20 more is 694. 19 less. Can you do that one in your head? Or do you gotta use a calculator for that one? I bet you can do it in your head. So 19 less is just like 20 less. So instead of 654, it's 655. 99 more, or 100 less. 99 more is just like 100 more, except it's 1 less. So it's 773. It's not quite 100 more, but 100 less would be 574. So that's how you fill these in. And with the newer ones, you have some doubling and halving and some fractions in there. Same idea. You're going to fill in the number from the number of the day. All right, let's take a look at some slides here. All right, so for this one, you have to make the pattern. You have to decide stage 4, stage 10, and what is the rule for each stage. All right, so how many cylinders in each stage? Well, we've got, if you look at your pattern here, and there's going to be different answers for this, and depending on your thinking process, but you see, okay, there's 5 here. How do you count your 5? Some people might go, okay, there is 3 in the center and 2 on the ends. Some people might go 3 this way and 1, 2 that way. You look at the next stage, stage 2. So there are 4 across, or there are 5 down here. There's different ways of looking at that. So what your goal is to eventually write the equation. But if we take and look at the pattern here, so like for stage 1, there are 5. For stage 2 is right here, so there are 1, 2, 3, 4, 5, 6, 7, and 8. Stage 3, we've got 1, 2, 3, 4, 5 going this way. And then there's 1, 2, 3, 1, 2, 3, so we've got 5 plus 6, we've got 11 there. All right, and after you draw stage 4, you bring the cylinders down and draw stage 4. What you need, figure it out based on the pattern. So it's 1, 2, 3, 4. And put in number 4. Then figure out what number 10 should look like. Right? How many cylinders should there be in number 10? How many going across? How many going up and down? And what would be the rule then? Using C, using N, what would be the rule for any stage? Not just these stages, but any stage. So for any stage, think about what is our independent, what is our dependent variable. What changes and what stays the same? What do we know? What do we choose? And what do we want to know? Think about what we want to know with these. We want to know how many cylinders. So we would write some sort of equation that starts with C equals. And then we would need something to happen to N, the number of stages, whether it's stage 1, stage 2, stage 3, or so on, to get us to the number of cylinders. So we would need something and something else. Maybe a plus, minus, multiply, divide, something in there that has to happen to the N, the number of the stage, to get us to the number of cylinders. And it would have to work for all stages, not just one of them, but all of the stages. So that pattern would have to work for all of them. So I'm not going to give you that answer just yet, because there might be different ways of figuring that out. All right, moving on to the next slide. Okay, this one is just a pattern of temperature changes, so be careful with this one. So far the work that I've seen, you guys are pretty good. Just be careful. This one is, the first box here is about the temperature in a few hours from now. Question B is about temperature before now. 1 hour ago, 3 hours ago, 4.5 hours ago. Thinking about like how fast has the temperature been changing, and what would it have been an hour ago? Right? For number 4, slide 4, this one, I saw a few people confused on this one. This one, you have to choose the true statements out of A, B, C, D, E, F, or G. Some of them are true and some of them are false based on the graph, based on how they describe the graph. If you think A, if you read A and it says one solution of the equation is 3, 2, if you think that is a true statement about this graph, then you would take a circle over and put it over A, like that. Okay? Likewise, if you think B or C or D or E or F or G are true, you would take a circle for each one you think is true and put it on there. Not all of them are true. Not all of them are true. And so that means you will not use all the circles. Right? So make sure you read that carefully. Think about that. Take your best guess, too, if you don't know. All right, and finally, this slide. This one is just more of just a fun activity you can do. Do it with your kids, whatever. This is called a Mobius strip. This is an interesting way of doing a strip of paper. If you take a strip of paper and follow the directions there on the paragraphs, and you flip one end over, tape it together, and take a marker, take a pen, and start drawing a line on one side, all the way around. Keep going until you get to you go all the way around, and see what happens. See what happens to that line that you draw. Can you predict before you do it? What do you think might happen before you do it? If you need a little bit of help on building a Mobius strip, you can click on the YouTube link here. And this Mobius strip is kind of a fun thing to do. It's just a little activity. There's nothing you have to type on here, nothing you have to upload, but just a fun activity that you can try and see. Just explore some stuff there. All right, so that's how we're going to do these slides. All right, number of the day, various types of questions, maybe an activity or two. All right, I'll be posting a few more later on.